Okay, sports fans, we're like a day or two away from your test, and momentum is this big idea that we've been covering. And just recently, we taught you that momentum is conserved, right? So we've been working through these conservation of momentum problems. I just want to do an example to have you refer back to. We worked through this worksheet. We did the first 5 on the back. I'm going to work you through number 6 right now. Take a quick look at this one, okay? Terry, a 70-kilogram tailback, runs through his offensive line at a speed of 7 meters per second. Isn't Terry so fast? That's great. Jared is a 100-kilogram linebacker running in the opposite direction at 6 meters per second. He meets Jared head-on, and it says it wraps him up. So what they're trying to say is they didn't bounce off each other, but they became one moving object during the tackle. And they want to know what is the result of his tackle. So essentially, who wins? So we're going to use this as a conservation of momentum problem. We're going to start off by drawing what happens. We have 2 people coming towards each other. They're going to collide, and after that collision, they're going to stay together as one body. But we got to figure out who wins the tackle. Which way do they go? Do they stop dead in their tracks? So start off by drawing it. We've got, as it says here in the problem, we've got Terry moving one way, and then we have Jared moving the other way. Terry is 70 kilograms, and Jared is 100 kilograms. So let's do it. Up here, we want to show that we have one football player, right? Can't you tell that's a football player? He's moving in this direction. He is a 70-kilogram person, and he's moving at, let me check again real quick, 7 meters per second. And the other player is moving in this direction at 6 meters per second. Not quite as fast, but they have more mass. This is a 100-kilogram linebacker. Okay? So they're going to collide. What we want to know is what happens after the collision, right? After the collision, we know that they're both going to be wrapped up in this brotherly love of a tackle, but we want to know which way they go. Do they continue to move in Jerry's direction, or are they going to end up moving in Jared's? Oh, Terry, I mixed them up. That's Terry. Let's write these names out, shall we? This is Terry. Nice to meet you, Terry. And this is Jared. Right? So who's going to win? What they're really asking is who's got more momentum. So we're going to use our momentum equation to figure out, first of all, who has the most momentum going into this tackle. So our momentum equation, we know, is mass multiplied by velocity. And so for Terry, we take a mass of 70 kilograms and we multiply it by a velocity of 7 meters per second. And that's going to end up giving us a momentum of what? 490. And these are kilograms times meters per second, right? 70 times 7. Is that right? Cool. I don't have my calculator. Oh, here's my calculator right here. So let's figure it out for Jared then. Jared, if we use the same equation, mass times velocity, his mass is 100 kilograms, and he's traveling 6 meters per second. When we multiply those together, we get a momentum of 600 kilograms times meters per second. Okay? So from this, we've determined the momentum that Terry has going to the right and the momentum that Jared has going to the left. Now, it's an oversimplification of a tackle. Sorry, we're not trying to offend any actual football players out there. But if we kept this as just a momentum problem, Jared's going to win this battle. We know that these two, once they get tackled and they wrap up, will be moving in this direction because of the momentum that Jared has. He has more. If you take the difference of those two numbers, if you take Jared's 600 and minus Terry's 490, we know that not only are they going to be moving to the left, but there'll be a momentum of them moving to the left. Their momentum will be 110 kilograms times meters per second. Just the difference of those two numbers, and that's to the left. Okay? So the problem doesn't ask us to calculate any further, but why stop there when we can have a little bit of fun? Why don't we figure out how fast they're moving to the left, after this tackle takes place, assuming that they wrap each other up. So we know how much momentum they have. We also know their mass because we knew their masses individually, so we would just add the two masses up. If we want to know how massive these two guys are when they're wrapped up together, we'll take the mass of Terry, which is 70 kilograms, and add it to the mass of Jared, which is 100 kilograms, which means we know their mass is 170 kilograms. So the only thing left to ask now is how fast are they going? If you take the velocity equation and the momentum equation and rearrange it for velocity, we figure out that velocity is equal to the momentum of the two gentlemen divided by their mass, both of which we already know. We know that their momentum right here can be plugged in, and their velocity would be 110 kilograms times meters per second divided by, once we plug in their mass of 170 kilograms. Mathematically, now we just divide those two, okay? We know that kilograms cancel out. We're left with meters per second, which is great because that matches up with what we're trying to solve for. Let's go to the calculator here, and we'll do this one. 110 divided by 170 gives us this number right here, right? It's less than a meter per second. We go ahead and round that to 0.65. 0.65 meters per second. That's how fast they're going. All right? Not particularly fast, but remember this is after the tackle. Some of you might be asking, why did we subtract their momentums? Well, remember we had Terry moving this way, and we had Jared moving this way, and those are vectors. When they're in opposite directions, we subtract. If vectors are ever in the same direction, then we add up. Okay? So you got more questions, come in and see me before or after the test, hopefully before, and we'll get them figured out.